Hello, I'm Dean Stanberry. I'm IFMA's first vice chair of the Global Board of Directors, and I'm pleased to be introducing our topic here today, which is integrated systems packages. IFMA has a long history and partnership with the Department of Energy and their Better Buildings initiative, and this is one of those activities that we have participated in. So thank you for joining our live stream today. While we're waiting for everyone to join, please go into the comments and let us know where you're joining us from. Our panelists are going to present, and then we will have opportunities for Q&A at the end. So go in and add your questions. We'll start collecting them as we go along. So please enter them in the chat. And also make sure that you like and share this video so we can help other FMs like you. So moving on to introduce our panelists for today. First, we have Paul Matthew, the staff scientist at Lawrence Berkeley National Labs. Dwayne Kubishta, engineering manager with KW Engineering. And Alex Kafka, senior partner with Verdera Partners. So Paul, why don't you tell us a little bit more about yourself and turn it over to Dwayne then.
Great, thanks so much. I'm just going to go into present mode here. My name is Paul Matthew. Thanks, Dean, for inviting us to present on this IFMA webinar. I lead a bunch of applied research projects here at Lawrence Berkeley National Laboratory, and I lead the Integrated Systems Package project that we'll be talking about more today. Dwayne?
Yeah, hi everyone. My name is Dwayne Kubishta. I'm an engineering manager with KW Engineering. I've been in the energy efficiency field for about 12 years and happy to help out Paul on some technical resources for this project and share some of the case studies today. So happy to be here. Alex?
Thanks, everybody. Alex Kafka. I'm a principal at Verdera Partners. We're energy engineering consultants. Our focus really is deep energy retrofits, so you're going to be hearing about that today. We have a specialization in retrocommissioning, HVAC, lighting systems, solar and batteries. And really what we do is we help facility managers get their smart energy projects approved. The way that we do that is, kind of our special sauce is developing plans and scopes of work that are financially optimized to your organization's goals. And, in plain English, that basically means helping you get the most possible savings at the highest possible at or above your return hurdle, maximizing NOI, maximizing building value. If you're a nonprofit or a educational institution, really kind of helping you stretch your operating and capital budgets. And a great example of stretching capital budgets is using the ISP resources that you're about to hear about today.
Great. Thanks so much, Alex. And I just want to confirm with Dean that you can see the slides well here. Okay, I'm going to assume that that's the case. All right, so first, I want to talk a little bit about the motivation for this work. With many building owners and actually cities and states and jurisdictions have set goals for deep energy savings in existing buildings. And that can be a bit of a challenge, actually. And these deep savings actually require not just component-based retrofits, such as just a lighting upgrade. They require integrated systems packages, bundles of measures, essentially, across lighting and HVAC and so on. So the good news is that we sort of have the technology for this already. The New Buildings Institute maintains a database of net zero buildings in the US, and there are over 700 net zero buildings already running and operating today. So, we have existence proof that this is possible. Granted, many of them were new construction, but there are some retrofits as well, and those technologies certainly apply in the retrofit context as well. The challenging news is that retrofits are still often too disruptive because they're not aligned with the real estate lifecycle. They still require significant engineering expertise, really a committed owner, operator, designer, commissioner, and so on. Utility incentives can often be kind of burdensome, because you often have to go the custom path as opposed to sort of a deemed savings approach. And there are lingering concerns with savings uncertainty and savings persistence. So the bottom line is that, yes, we have the technologies and they're commercially available and they're very often proven, but it's not easy to implement them. And that in turn hinders sort of scale adoption beyond sort of the leaders to meet climate goals. So what do we do about this? So the whole idea with ISP is a strategy that has kind of two components to kind of make it easier in a sense. The first is to create packages of measures that are kind of quasi-standardized, they're sort of pre-engineered to help de-risk them and reduce the transaction cost. In a sense, the sort of the hassle factor of implementing these measures. Of course, one can never completely standardize. Every building is a snowflake is a common expression. I think we all understand. But kind of move down that standardization spectrum so that you're not always starting from scratch. The second is to align these bundles or these packages of measures with the scope of particular real estate lifecycle events, because that helps reduce disruption and increase cost effectiveness. So the vision really is that these integrated systems become kind of a low risk, almost like the default option rather than sort of the fancy option when you're in these real estate lifecycle events. So what do we mean by real estate lifecycle events? So this sort of simple schematic kind of lays that out. It's somewhat simplified, but if you look at the life cycle of buildings, they get bought and sold, they get renovated, you have tenant fit outs that happen, equipment gets replaced when it dies or when it's near end of life, buildings get refinanced. Each of those events are a potential opportunity to incorporate energy efficiency. So instead of energy efficiency retrofits being sort of a dedicated project somewhere in the middle between these events and therefore being disruptive, they can actually just be embedded right within each of these events. So for example, at the time of a tenant fit out, typically you get to retrofit, change the lighting, maybe do some things around HVAC controls. And of course, you do other things like change the carpet and paint and so on. So the idea here is that let's create a package of measures that is tailored to the scope of that tenant fit out. Likewise, when you have equipment replacement, for, say, an RTU, instead of just doing like for like, you could do a high efficiency RTU, combine it with some heat recovery, demand controlled ventilation, some additional retro commissioning, for example, and so on. So that's sort of the idea. So the way we went about this was that we first, several years ago, we just generated a huge laundry list of various proven efficiency measures. What we then did was that we said that, okay, let's look at each of these real estate lifecycle events and figure out, would this measure apply in this event or not? So for example, at the time of a tenant fit out, lighting upgrade, sure. Chiller retrofit, not so much, because that's just not within the scope really of a tenant fit out typically. And then we looked at the potential for standardization for each of them. And so we essentially culled down that big laundry list of potential efficiency measures and figured out what would be kind of appropriate for a given real estate lifecycle event. And this is where we ended up. So we looked at 3 events: a tenant fit out, an RTU replacement, and a building renovation. For the tenant fit out, we said you can certainly do advanced lighting with daylight dimming controls and so on. Incorporate HVAC controls using ASHRAE Guideline 36. Optionally, one could include, if it's appropriate for the building, you could include ceiling fans with a 4-degree Fahrenheit set point increase, automated interior shades, and plug load controls. In the case of an RTU replacement, in addition to obviously a high efficiency RTU, you could add in again these Guideline 36 controls, low pressure drop filters, and optionally, if it works out, you can do window films and cool roofs to help reduce the load on the building and downsize your RTUs at the time of replacement. And a building renovation is essentially all of that with a couple of more things added. Important thing to note with these is that these are not fancy measures, and that was intentional by design. We want to take proven measures that are economically sensible as well, and essentially package them and standardize a set of specs around them so that they become easier to implement. So then our next task was, let's do some testing of these measures in both the laboratory and in the field. So with laboratory testing, we have a facility at our at Berkeley Lab called Flex Lab that we use to test this. And the purpose of the testing was to look at what the actual energy savings are from these measures, look at thermal comfort, illuminance, and glare implications, so essentially indoor environmental quality aspects, and also look at things such as installation and operation. And the nice thing about doing testing in a laboratory as opposed to a real building is that, if there are commissioning problems or installation problems, you're not messing with a real building. You're actually it's just in a laboratory. So this Flex Lab test facility, the photograph on the right shows you a photograph from the outside of one of the test beds at this facility. And each test bed has 2 test cells. And so one identical test cells. So one test cell we set up as sort of the baseline condition, say a 1980s or 1990s vintage office space. And on the right side here, we have the actual test case, which in this case is an ISP retrofit. And the photograph actually on the left shows you the interior of one of these cells set up for the ISP retrofit. And you can see we've set it up like, an open office cubicle area. You can see the automated shades, the ceiling fans, the automated lights. And then we want to test the full integrated energy effect. So we actually have heated mannequins that represent the amount of heat that a human being puts out. And then we have, the plug loads, computers, and so on that turn on and off as though people were there, and so on. What we could actually do is that we tested with various configurations, with the optional packages or not, and then we tested different orientations. This test bed is actually located is situated on a rotating concrete pad, so that we looked at a south orientation as well as a west orientation, in case your facade is obviously west facing. You could also north and so on, although we limited the number of options we looked at over here. So I'm going to run this little video that shows you sort of just sort of a quick time lapse video over the sequence of a day, and you'll see the lights here turning on and off, pretending that the occupants are kind of leaving. So the lights change, the shades go up and down. You'll see that in the back over there, based on solar conditions outside. And in a second here, you'll see the ceiling fans come on. So they came on for a little bit, and so on. So we did this testing over a 6-month period to kind of capture all the different seasons, and see where we end up on that. So the results, pretty amazing results for what are pretty modest measures. With lighting, we found on the order of 70 to 85% savings of the lighting end use itself, and about 7 to 15% of that was just from daylight-based dimming. The rest was just from the upgrade itself. On the HVAC side, and again, this is HVAC, remember, and tenant fit out is just controls, actually. So just from the controls, we saw 20 to 40% savings. And the range, by the way, is because of the various combinations and orientations that we tried. Plug loads were much more modest, as it turns out, in terms of the plug load savings. And the combined across all of those measures, all of those end uses together, was on the order of 33 to 40% savings that we found from this laboratory testing. So that's obviously just, you're probably thinking in your mind, okay, that's a laboratory test of sort of a one cell, which is kind of represents a perimeter zone. What about what's the effect at the whole building level? So we actually ran energy simulations using Energy Plus, well-known energy analysis tool, simulation tool, and we did this for a medium office building. I'm blanking out now on the size of it. I think it was about 50,000 square feet, at post 1980 vintage. And this shows you for the tenant fit out ISP what the site energy savings are. So this is at the whole building level, site energy savings, electricity and natural gas, for 4 different locations: Houston, San Francisco, Chicago, and Denver. The hashed is with the core measures, and the solid is the core plus some optional measures. So what you'll see here is that pretty remarkable savings, again, for pretty modest measures at the site level, right? I mean, on the order of from what here, about 25% to 35-ish percent site energy savings. If you remove the HVAC and just do lighting, just as a point of comparison, that cuts in about half. So, the HVAC controls, it's not just really all about the lighting, it's the HVAC controls really made quite a difference here. For the RTU ISP package, that's what you see on the left here. The savings site energy savings are on the order of just about 10% to 15 to close to 20%. And then on the, if you do the RTU with the tenant fit out, so whole building renovation ISP package, the savings are, of course, much more, and they vary from as low as 25 in the case of Chicago's core only package, as high as close to 45 in San Francisco's core plus option package. So again, I think I want to emphasize that what we see here are some pretty solid savings, site energy savings. Generally, the question of deep is how much is deep? Well, anything above 20% is in retrofits is generally considered deeper energy savings, and we can do these with pretty modest measures. I mean, these again not cutting edge measures at all. So with that, I'm going to turn it back to Dean to continue with the presentation here. So.
Come off of mute. Thank you, Paul. Good introduction to the integrated systems packages. So we're going to bring it on to Dwayne, who's got a case study for us. So Dwayne, maybe you can start off by just talking a little bit about, why did KW Engineering take a look at the integrated systems packages, and how did you find out about them, and how did you decide to use one for this particular case study, and then show us what you got.
Yeah, Dean, thanks for that. Yeah, just to clarify there, KW Engineering served as sort of a technical resource for Paul's group on this study. So we didn't actually, bring it in as an owner's rep or efficiency rep for this particular case study. But we were happy to provide engineering resources for the team and go through the M&V steps to sort of prove the savings, and happy to see real case studies show and justify, substantial levels of energy savings that correspond with the energy models and the testing that Paul's group did. So I'll get into it with our first case study here. Great. So yeah, this is actually a bank office building. So kind of a little bit more on the retail side than like a straight up office, but they did have some office areas of this. So the lower floor was the actual bank branch, and I believe the upper floor had some staff offices. It was kind of a regional facility for the bank branch, basically. This particular location was in Birmingham, Alabama. We're about just under 9,000 square feet, and the building vintage is about 2006. Envelope was double pane windows, brick veneer exterior, and we did have DX package units on the roof. Actually still had electric heat. That's a little more common in this area of the United States than we ever see in California here, where I usually operate. And the lighting was 2x4 troffers and can lighting. So we can go to the next slide. So yeah, just to put the energy savings here right up front, we did see about 25% energy and greenhouse gas savings on this project. There was the addition of PV, which did add a little bit on the greenhouse gas side. The PV actually makes it a little harder to do M&V, but we were able to incorporate that data in. So all the data numbers that we present on the next slides incorporate, a like-for-like comparison. But let's go ahead and slip to the next one. Yeah, so this just shows the savings over the kind of the course of an average day. And from this, you can see that we essentially do get off-hour savings, so those early mornings and those late nights. We do have significant savings during the day, and we can also see a significant scheduling shift as well. So instead of going late into the night, we have more occupancy-based controls that turn things off. I don't remember scheduling being specifically addressed here. So it's actually really nice to see the post retrofit really show you that savings from the scheduling, because we didn't come in as like, oh, there's a big scheduling measure here to tackle. But it's nice to see that all the controls and just the attention on it actually gave us that good amount of savings in those evening hours when the facility is lightly used. So let's go to the next slide. This slide just shows the savings over the course of the year. And from this, you can really see that savings are mostly in the middle of the year. During the colder winter months, we did not see as much savings. And I kind of attribute that to the electric resistance heating still being there. There was not an easy way to remove that. We did lessen the amount of time that was needed, but still during those colder core of winter months, there's not much energy savings. But during most of the rest of the year, when the temperature is a little more mild or warmer, we essentially have our most amount of savings. So great to see that as well. And then let's go to the last slide. So key takeaways here. Again, routine proven measures. So actually I'll talk a little bit about that. So we did do lighting and HVAC. This project sort of started out as a core lighting retrofit, and we incorporated in the HVAC, and just the easy wins there. The comment I like to do is the contractor actually said, when we were discussing adding the HVAC measures, and we went through like supplier temperature reset, duct static pressure reset, there was one line where he was like, yeah, we have everything we need to do that DSP reset. We just need to turn on and enable those controls essentially. And it was just like, that's the kind of key win where you can incorporate more into these events and really get a lot of bang for your buck out of that. It was just like, that was a slam dunk. Yes, we'll do the duct static pressure reset. We already have the VFD. We already have a sensor. Let's just turn that on with some controls. So it was a great win to see that. Couple other points here. Yeah, just, the ISP template specifications were used to help reduce the level of effort. We had specifications that the contractors could go through and say, like, yes, we can do that. Yes, we can do that. Hey, this one's a little hard. Maybe we need to discuss that a little more. Again, getting to those site-specific nuances a little bit there too. But overall, the contractors were pushed, and the end result is that we got a little bit more out of having that standard list of measures in front of them. And then, yeah, to my point, I think a little bit, Guideline 36 will require some customization. I think I kind of touched on that earlier. There were some things that we could not do. I think specifically for this one, it was a little bit around the deadband sequences. They had sort of unique situations with how you deal with having a cooling set point that's offset from a heating set point. That wasn't a standard way that we could do it, just based on the controls that they had on site. I think I'll end it at that and pass it back to Dean.
Okay, thank you, Dwayne. One thing I'll just remind everybody, IFMA is very committed to, the sustainability and climate action. And if you don't know, commercial buildings account for roughly 40% of carbon emissions globally. And so facility managers are sort of uniquely positioned because they control the operation of the building over its life cycle. We're uniquely positioned to help reduce those carbon emissions. And so when we see things like opportunities to simple things that can reduce energy consumption by 25 to 40%, that's something we need to take a look at. So we're going to turn it over to Alex now to talk about, his case study. And so Alex, again, how did you get involved with the integrated systems packages, and how did you choose this particular case to work on?
Thank you, Dean. We got involved to really kind of leverage the templates and the resources that DOE and the ISP program specifically has available that can significantly reduce the soft costs involved in developing projects like this. And because we work as an owner's representative, our interest was in how do we kind of take and be smart with the resources and the financial resources. And so taking advantage of the, resources that the ISP offers and the best practices as well was really kind of a key, objective. So the case study that I want to talk with you about, we literally just kind of finished wrapping up this project. We're doing training with the client in a couple of weeks. So we're kind of at the beginning of the M&D period. But what we have here is a whole building retrofit involving all new rooftop package units and advanced controls implementation on about a 20-year-old building that's mixed use, mostly office, but with some ground floor retail in the California Central Valley, which for us is a pretty extreme climate. You get the real high highs, triple-digit heat, and kind of colder seasons for California. So next slide. So what you see here is a bunch of gory pictures. Clearly, we've got an end-of-life situation. I mean, pictures are worth 1,000 words. Replacement is required. How do we go about, the question is really, how do you go about doing it? So next slide. Something to kind of keep in mind, kind of keep on rolling that there if you don't mind. Thank you. Just kind of as an analogy, you buy a house and it's got a 1970s kitchen, and the first thing you're going to do is you're going to modernize the kitchen. You're going to retrofit it. So the last thing that you want to do is take the 1970s dishwasher and put another 1970s dishwasher, into the kitchen. I mean, you're going to put a new Bosch or other kind of dishwasher in that's going to reduce energy expense, that's going to reduce water expense. And so, maybe you're justifying this to your spouse, and you're like, look, I'm going to spend the extra money on the better dishwasher, but we're going to get a payback on it. We're going to spend less energy, we're going to spend less water. The same thing is true for energy retrofits. So next slide. Keep going, please, if you don't mind. So we ended up here with a contractor-led project for part of the project before Verdera got involved. And what you're about to learn is that the owner overpaid. And so the owner didn't really understand and ended up getting kind of a like for like efficiency. I mean, slightly more efficient units because they're 20 years newer. The code has changed a little bit, but otherwise code minimum. And because the building had a lot of problems, the decision was made to upsize the tonnage when it wasn't really necessary. So the owner ended up paying for increased tonnage to try and solve problems that could otherwise have been corrected through a little bit of engineering work. We had the situation with tons of hots and colds. So we have these zones kind of stealing hot air or cold air, I should say, and hot water from each other. Not a great situation. So Verdera got involved. And what actually did not happen is what you're about to see here. So there was, this says contractor-led controls replacement. If that had been the case, what we would have ended up having was new VAV controllers and a new BMS. Keep going if you don't mind, Paul. But we ended up, that would have kind of left the existing defects in the building, would have kept installation defects from being caught, and would have had the advantage of a faster implementation, and kind of on a total soft cost and hard cost basis a little bit less cost, but as you're about to see, would have actually been a lower return. And so what Verdera ended up doing is keeping the mechanical contractor and just making them smarter. So working for the owner, keeping otherwise keeping the same folks, putting in an open source BMS package instead of the manufacturer, the rooftop unit manufacturer's closed protocol BMS. Also ended up getting new actuators for the VAVs, added in test and balance for the air side of the system. Really critically important. Everybody, Paul and Dwayne are going to kind of echo this. It's critically important that you involve an independent commissioning agent. So Verdera's commissioning agent going in to kind of look at the building, look at these existing conditions, catch issues, and then look at the new equipment, the new controls installation, catch issues there. And then really critically, and this is the key point actually of this whole case study, where the savings come in is through the advanced control sequences. Otherwise, you're putting everything in and you get no return. I'm about to show you how that works. So let's keep going to the next slide. So what we actually ended up with here is kind of looking at the investment analysis. If we had gone with this, or if the owner had gone with this controls, contractor-led project, what they would have ended up with is essentially a 0%, ROI. They would have had no energy savings whatsoever. And then if you look at the next example, what you end up with is you see that by enhancing the basis of design and going out and getting competitive bids, we're able to start to extract some additional savings with a very modest increase in the overall price from what the contractor-led baseline cost would have been. So maybe another $15,000. But then you see what really happens here that's dramatic. And can you roll forward one more transition there? Thank you, Paul. What you end up seeing is when you add the advanced sequences in and the savings associated with the advanced sequences, you're getting two things here. You're getting a significant amount of energy savings. So you're investing maybe another $50,000, $55,000 in this case on top of the original kind of contractor-led baseline cost. So there's definitely some additional cost, but you end up getting at this point significant savings, not just in the kind of energy, aspects, but because the hots and colds are down by about 95%. You end up getting significantly less truck rolls, and maintenance calls and so forth. And so there's we're anticipating a significant amount of, operations and maintenance savings as well. So you're seeing here actually the first time that there's a real kind of attractive ROI on this project is by implementing the advanced sequences, and you've got double-digit returns. Next slide. So keep rolling if you don't mind. Thank you. When you one more, there we go. Thank you, Paul. So one of the things that we like to talk with owners about when we're in the training process is, and same thing with respect to facility managers, facility engineers. The last thing that we want to be doing is asking or having you do kind of central kind of BMS system adjustments to the central RTUs and so forth. It's kind of like shooting your foot off, or as you can see here in the cartoon, cutting off the branch you're on. Next point, please. What we try to do in the kind of training process is explain how to do some basic diagnostics. So not just how to do something, but why you would do something. So if you get a hot or you get a cold, what to look for. Next transition, please. And then, when you can't fix the problem, focus on that last bullet. The last thing we want to do is to start to kind of play around with the kind of systems in the building just to optimize for comfort, because then then the whole reason that you sold your project is that you're gonna lose that. You're gonna lose the energy savings, and so we want to continue to kind of optimize both for comfort and for energy. Next slide, please. And then the first bullet, please. So kind of key takeaways here. If you noticed in this, we're kind of trying to emphasize the like-for-like project where you're going back and putting just the same rooftop units in and the same controls package is going to give you kind of certainly the lowest first cost. It's going to be faster, but it's next slide or next transition, please. There's a much smarter way to do it, which is to both optimize for both operating savings, which is not just energy, but also O&M costs, truck rolls and maintenance time, and comfort. And the way to do that is to implement kind of an advanced controls package. Next slide, please. That's going to cost more, and it might cost up to 50% more, both in terms of soft costs and hard costs. But by leveraging ISP and the resources that Paul Matthew and the DOE has put together, you end up with some significant leverage on the soft cost side of things. So that's really helpful, and it could potentially help you drive down some hard costs too. And then really critical, call it find and fix, another name for kind of independent commissioning. You got to go through and actually understand your existing conditions. If you don't fix existing building deficiencies, it's going to totally, it's going to completely undermine the results of your hard work to put together a better, smarter package. So fixing those kind of deficient base building conditions or deficient TI conditions. And then really critically, no one's perfect. Even a great mechanical contractor like we had involved here and a good controls contractor, they're still going to make mistakes. And so you have to have an independent commissioning agent, really kind of an insurance person for everybody, going through and kind of finding problems so that you can eliminate those variables later when you're kind of truing up the system. Next point, please. Doing those things and being smart about it gives you a double-digit ROI on that incremental investment above and beyond just the like-for-like baseline replacement. And I think that's my last point, and thank you very much. Back to Dean, I believe, or to Paul Matthew.
It's going right to Paul.
All right, great. Thank you very much, Alex. And Dwayne as well, and Dean. So just to wrap it up here, I think a message for everyone that you've hopefully heard a theme coming here is that don't lose the opportunity of these routine real estate lifecycle events to kind of add in a little bit of add in some efficiency to, and even modest measures can get you some pretty good savings. And then the second point is that we do have some toolkits and resources that will help reduce some of the soft costs there. And so we'll of course distribute these slides, and you can see here's the website for accessing some of these. Includes an applicability guide. There are design installation specifications, kind of like templates that you can just take. Obviously, you'll need to edit it, but it's a good start and a good time saver there. We of course have data on the energy performance, including some of the results I shared. The case study that Dwayne presented is also on there if you want a nice little fact sheet on that. We have functional test protocols, and we also have some maintenance guidelines. And so these can be used by owners and tenants. You can incorporate these standard specs for fit outs, for replacements. Obviously, if you're a designer, you can use it to help reduce engineering effort, as we mentioned, and so on. And I think there are benefits for some other types of stakeholders as well. And then finally, I just want to put in a quick plug for what's soon coming down. We've focused mostly on packages for office buildings. We've also got a set of packages for schools, a similar set of packages for schools around chiller replacement, boiler replacement, RTU replacement, and BMS replacement. So again, the idea here is that when schools need to do this for other reasons completely independent of the energy efficiency or sustainability, there's a bunch of things you can tack on essentially to that scope of work in order to get a bit more bang for your buck. So those packages are coming soon. We're very close to finalizing them and releasing them probably in the next couple of weeks or so. And we've also done a lot of energy and cost analysis on these packages. And we found that these are again routine measures can get you pretty meaningful energy savings with very reasonable cost effectiveness. So don't miss these opportunities to kind of incorporate energy and reduce GHG over time by incorporating these measures. So with that, thank you very much for listening and for this opportunity to present. And I will turn it back to Dean.
Okay, thank you, Paul. Paul, if you wouldn't mind going back to your ISP toolkit slide for just a second.
Oh, sure. I'll go there and just go back to present mode.
Get that. Yeah, there we go. I just want to point out, so we do have the part of the purpose of this is that DOE, Department of Energy, and the Better Buildings Initiative, these are all taxpayer funded initiatives. So basically, the output of this is freely available to anybody. And so by going to that website, you can get any one of these toolkits. And again, it reduces a lot of the friction that you have in putting together some of the cost proposals, the energy savings opportunities. Again, you're getting the maintenance guidelines and the testing protocols, just handed to you. So for facility managers that often are struggling to say, I know I need a new rooftop unit, but time and money, we need to just get it done. This can help you still get some energy savings and some benefit, and prove out the cost benefit of doing some of these changes. So for our IFMA staff, if you could take that link and put it into the chat for people so that they can grab it, that would be great, because I know a lot of times it's hard to get all the periods and the dashes and the slashes and everything in the right place. Now let's go back to the final slide, if you would, just to start closing things out. I think I got it, something. Did we have any questions in the chat so far? I think that's a no. So let me put one out there. So beyond the toolkit resources, what other technical support is available through the ISP program? And Paul, I think that probably starts with you.
Sure. Yeah. I think. Well, first I'll mention, Dwayne, you very kindly plugged the Better Buildings program at DOE, and one of the things I'll mention is that the Better Buildings program has what they call a solution center, and I think there are thousands and thousands of resources out there. I mean, everything from guides to case studies to template specifications for a range of different building types, cost and analyses, and so on. So I'll just if you type in Better Building Solution Center, and then you can do a search by building type or region and so on. So there's a bunch of resources out there to help reduce soft costs and so on. Then also there are programs, there are various programs that can offer technical assistance for those that are trying to implement these measures. And I want to be clear that this is it's sort of limited technical assistance. It's not we're not going to obviously do your design for you. But the idea is that if there are particular challenges or you're having a hard time kind of selling the idea, you need sort of a third-party person to kind of help validate savings and so on. That's where some third-party technical assistance can really help. So that again, it varies. I mean, there are things related to office buildings. There are things related to sometimes it's also by technology, lighting versus RTUs and so on. So that again, if you go to the Better Buildings solution website, you'll see these different campaigns and ways to access technical assistance. Right now, I'll just mention quickly the Department of Energy is running a Better Climate Challenge. And that's essentially where somebody signs on to say that, yes, we have these goals, we're going to try and meet these goals. and then a bunch of technical assistance from the national labs, DOE national labs, can be provided to those building owners to help meet those climate goals.
Yeah, Paul, thanks for mentioning that. And as a matter of fact, IFMA is a registered ally for DOE for the Better Climate Challenge. So there will be more coming around that. They've already got a number of programs. Some of them are pretty high level, but there will be more things getting down to, I would say, the day-to-day operations level very soon. So, stay tuned for that. Another question might be how easy are these toolkits to use? Are they accessible to the average facility manager or a building engineer? And Alex, what can you offer up on that one?
Sure. Yeah. I mean, thanks, Dean, and thanks for the overall moderation today. Our experience was amongst all the different kind of incentive or assistance programs, we had a terrific experience with ISP just because it was really fast. And so often when you're working with an efficiency program, particularly if it's, you're dealing with more complex systems, it takes quite a while to go through the application process. And, this was a kind of a much faster application process. And then we were right into getting resources available to help us. And so I think that one of the things that we sometimes on the owner side of things, as an owner's rep, we can struggle with is there are a lot of programs out there. There's federal programs, there's state level, there's sometimes local or utility level programs, and it's actually sometimes we have this kind of dilemma of too many things, and so it's helpful to know that you can go kind of right to the source. You'll get a live person. They'll kind of go through a qualification process, and once you're qualified, it's really easy. You get access to both, Paul and Dwayne and their resources to essentially help you kind of, figure out, okay, well, these are the resources that sound like they're best for you. And then they're easy to apply. So we had a really positive experience with this program and look forward to further interactions and using them on other buildings.
Okay. One more, and it's kind of along the same lines, but from a time, cost justification, cost savings perspective, what sort of value do the toolkits provide over the historical, design from scratch approach? And Alex, let me start with you.
Sorry, was that to me?
Alex, let me start.
Okay, great, thank you. So one of the things that we try to do is, there's soft costs and there's hard costs, and in developing a deep energy project, and so one of the great aspects of the ISP programs that you're leveraging the ISP specific resources and DOE resources in general, and then what that specifically meant for us is rather than having to develop the sequences of operations for the advanced controls, that we were able to obtain kind of a template and then customize that. Took it was on the order of $10,000, of value, just kind of immediately right there to a project. So that was really helpful. And then kind of one of the other key aspects of the assistance here was some assistance on the commissioning side, kind of reviewing and developing some of the functional test procedures. And then some real assistance on the measurement and verification, which we're planning to do on a 3-season basis. So not just, as the building is just the first few months after the building is brought online, which might be in this case the summer, but also looking at shoulder season and winter season results and kind of really verifying that we're actually getting the savings that we expected. So I'd say it was both on the kind of planning and implementation side, there was assistance, and also on the measurement and verification side. So pretty much soup to nuts through the project. And also just a plug, which is that the folks here they're nice to work with. So good people, and it makes a difference when you're working with friendly, smart people versus people that maybe don't have quite the motivation. So it was an enjoyable experience.
Thank you. Dwayne, building on that, so from a mechanical engineering perspective, what benefit does the toolkits provide, like for an engineer being able to pick this up and sort of like, I won't say shortcut, but focus a little bit of their efforts, rather than, again, going from the design from scratch.
Yeah, definitely add to that. The idea here, and it is that really there's something right in front of you that helps you do more. We have the cost justifications, we have the savings justifications. So if you need that aspect, we have some of the specifications developed and laid out in a way that's sort of, a little more simple and a little more clear. So that's like right in front of you as an engineer. You still have to do a little bit of the, cross-reference with, does this apply to my building? And maybe that's a discussion with the contractor. As Paul said, every building is unique, but we sort of have the resources in front of you that just make it easy to like sit down. Here's my checklist. Here's my list of extra measures. I'm going to go through those one by one. Just check off, have that discussion with the contractor, and really just push you to do a little bit more and have the resources ready to make that process a little bit easier. And as we can see from the case studies, there are great results in doing that. And so I think that's really, to me, that's the real advantage of this, is just having that, in front of you as a resource to use to help make a better energy impact on your renovation or your real estate event, basically.
Thanks for that. Paul, I want to kind of take that question then back to you. But you talked a little bit about how the program started. But coming out of Lawrence Berkeley Labs, this is a scientifically researched and vetted project. What was the length of time from the time that you took it over or started the project to the time that you had these toolkits and packages available? How much time did you spend doing all of this research and developing these solutions?
Yeah, and actually, first to I'll answer your question first, and then I wanted to add rip off a little bit of what Dwayne had said. So this was a 3-year project that actually is just about ending now. And so the first, putting the packages together, doing the Flex Lab testing and so on, was on the order of about 2.5 years. We had some COVID delays. So COVID hit right as we were going to do some, we were in the midst of some Flex Lab testing and so on. So ordinarily that was about a 2-year effort. I mean, the Flex Lab testing, there's just a matter of calendar time. We want to catch all the seasons. So, you have to catch it from summer to winter. It's typically from June through December, or, December through, or January through kind of June is the period in which you have to do the testing. So that's about the level of effort we took. And one thing I want to emphasize is that the process here wasn't, because we weren't inventing any new technologies here. I mean, this is, again, these are proven commercially available technologies, right? This was really about more like a design effort to figure out what makes sense and vet it with the real estate industry. So something I didn't mention was that we actually went through a pretty intense vetting effort and a stakeholder survey where we interviewed 33 different real estate organizations, owners and architects. We even talked to lease lawyers to understand what the leasing processes looks like for tenant fit outs and so on, to understand what the constraints are and what's reasonable to do in the context of each of these real estate events. So, and we have a public facing report on that as well on the same website. So anyway, we kind of went through that kind of a stakeholder engagement process to understand what the constraints are, and then went through the technical work of designing and testing it, of course. Since I have the floor, I just want to rip off a little bit more of something Dwayne said about reducing soft costs. I want to make this larger point, which kind of matters from a Department of Energy standpoint as well, or broadly from a policy standpoint, which is that we have this problem in the building industry and energy efficiency, which is that we have a ton of great solutions, as I said, commercially available. Many of them are even economically viable, right? I mean, they have reasonable payback numbers, and I realize, what's definition of reasonable may vary from owner to owner, but a bunch of stuff that's under 5 or under 10 and so on years. But even then, there's still a huge adoption gap, right? So you have technical potential, economic potential, adoption potential, and there's still at the end of the day pretty low adoption compared to what could be done that's economically effective. And one of the reasons, and that goes to this issue of what I call the hassle factor, which is that for many people, energy is just not that salient. It's not a huge cost for some people, or they've just got more important things to spend their time on. So anything we can do to make it easier and reduce transaction costs I think helps move the ball forward. And that's kind of what the ISP is about. But trying to reduce the hassle factor, the transaction costs, in order to enable more of this to be applied much more broadly. So.
All right, thank you for that. One other thing I'll mention, it's another private sector partner that has been working on this is Prospect Silicon Valley. They're actually sitting in on the call here today. They've been helping communicate and connect people up with this. They have also been working with Pacific Gas and Electric in California. So if you are in California and in Pacific Gas and Electric utility territory, they've offered up some pretty significant incentives that people can take advantage of. So if you're on and you have some interest in that, why don't you put your email in the chat, and one of the folks from Prospect will be able to get back in touch with you, that you can give you a little bit more information on that. We will be doing some additional communication on that program coming up, but I thought since we're here and we've got a little bit of extra time, we could mention that. So go ahead and throw that in the chat. I'm going to ask for our IFMA staff, do we have any additional questions that have come in? Anything from anybody that we can answer, because we do have some extra time here.
Yeah, Dean, Clint Jones asked, he says, with technology and its advances, do you provide those changes year to year?
I'm going to presume that what you're talking about there is, will these technology or these packages be updated, as technology changes? And Paul, maybe I'll just kind of throw that one back to you. I'm thinking that there's probably, it would have to be a pretty significant technological advancement to warrant updating how these packages actually work, but I'll let you take that.
Yeah, I obviously the packages will evolve. I wish in the building industry things change much faster, but it does. It's not like tech where every year something changes dramatically. I mean, in the building industry, the pace of change of technological advancement is much slower. So these packages will be valid certainly for the next few years. I mean, I can imagine on a cycle of on the order of 3 years that these packages would probably need to be updated. But I will mention one thing that has come up more recently is electrification, because a lot of owners have expressed interest in electrification, and do these packages address electrification? They do not explicitly right now, although we mentioned, if you're replacing an RTU, try to go all electric. We mentioned that. A second thing that we've not fully addressed that's also evolving is demand flexibility. So are there ways to incorporate demand flexibility, and that's really a controls issue, into these packages? So we do have a guide that we developed on how to apply demand flexibility. That's a little somewhat sort of a complement to these packages. So that's also on the website. I'll leave it at that. So short answer is yes, I can see on the order of every 2 to 3 years us updating these packages.
And Alex, I think you've got something to add to that.
Yeah, I think my role here in this whole one of the roles is certainly beating the drum for advanced sequences of operation. ASHRAE has been working on, ASHRAE and Taylor Engineering have been working on, developing these advanced sequences to really kind of take us from a 1970s or 1980s world of how do you kind of control your building into a 2020s world of how do you control your building, or the 2000s. That has been in the process for, in the background for many, many years, and has, been introduced a couple of years ago and is being, more widely adopted now. And that's an example of this current ISP package taking advantage of the latest and greatest knowledge, which has certainly evolved over time, and helping you implement it, and not just implement it, but implement it successfully. And understanding some of the pitfalls that happen when you try to go through the advanced controls implementation and how to avoid those. So all those resources are available, and I strongly encourage you to use them. And I also just wanted to echo Dean's comments about how grateful I am for Prospect Silicon Valley's involvement in helping Verdera connect to the ISP program And through that, we're able to bring those resources to multiple clients. So thanks again to Doug and Taylor from Prospect Silicon Valley.
Yeah, now there's a comment here. So we on the call we have Doug Davenport, who is the CEO of Prospect Silicon Valley, and he pointed out that if engineers, mechanical engineers, are picking up on these approaches, then those technological advances are kind of baked in, because they're already going to be aware of the advancements in technology, and as they're doing designs and so forth, and putting those requirements out to the contractors to source the products at that point.
Dean, I mean, I think back to that slide that I showed of, like, if you're gonna go through and you buy a new house, it's an old kitchen, you're not gonna put the 1970s dishwasher in, you're gonna put the Bosch dishwasher in that saves electricity, it saves water, and there's a payback to it. It's the same thing with respect to your retrofits that you're contemplating for your large building, your large TI. Why go back with 1970s technology? Why live in the past, right? What we want to do is kind of take advantage of the best that current technology has to offer, which right now and for some time is going to be the technology that's found in the ISP packages, that's found in the advanced control sequences that ASHRAE's developed, that Dwayne and Paul understand how to help you implement. And so, I think that the comment, I forget the gentleman that had, I think it was Clint that had the question. It was a great question. I think everybody is certainly concerned about, like, do we do this now and then we realize, or should we wait? And the answer is you should do it now, because it's taken, you should kind of go as advanced as you can now, because it's really taking the benefit of all this knowledge that's come up to this point. And you're cutting edge, and that's the best you can do, is be cutting edge today.
Very good. Well, we are coming up on close to the end of the hour. So I do know from working with some of the manufacturers out there, many of them are working on decarbonizing their products, but also upgrading to moving away from natural gas to electrification and so forth. But to Alex's point, if you got a need today, try to go as advanced as you can, because rooftop units have an average lifespan of 15 years. So you're probably not going to get another opportunity for a while. Other technologies go up to 20 years. So in order to hit some of these 2050 climate objectives, as we make changes today, we have to go as far as we can with the available technology, because we're going to be living with it for a couple of decades, more than likely. One last point I'll make about if you Google Better Buildings Initiative, it will probably come up as your first choice. Go ahead and take a look at that. As Paul mentioned, there's literally thousands of opportunities available there. IFMA is working with the DOE to actually identify the ones that are of greatest interest to the facility management community, so that we can populate our knowledge library with links to those items to make it a little easier to find. And Paul also mentioned demand. One of the things that you can find on through the Better Buildings Initiative website is DOE's Grid Interactive Building Roadmap. So if you're interested in those topics about where is the energy grid going, and it's going to become interactive, we think of it as sort of a one-way pipe. You deliver energy to buildings. It's going to work both ways, because we now have lots of renewable energy, and that's where a lot of the demand response flexibility is going to be built in. So for a facility manager that's in mid-career, you might want to start looking at that, because it will be coming your way while you're still operating buildings. And with that, I'm going to thank everyone at IFMA for putting this on today, and thank all of our panelists for joining us and giving us this great commentary. And if you would, remember to join us at World Workplace, which is held September 28th through the 30th in Nashville, Tennessee this year. It'll be a fun time. It's a great opportunity to build your professional network and learn from other thought leaders in FM. So I'm going to leave it at that, and we will be posting this video as soon as we can get it produced.
Thank you, everybody.
Thank you all.
Great, thanks.